So after applying the Bernoulli's formula, you will get the formula like this: 1 minus half minus 1 the whole power n. So whenever you're having the format like this, 1 minus half minus 1 the whole power n, the next step will be you have to check whether this function is available for all the numbers. If n is an odd number, for example, you just take n equal to 1 here. If n equal to 1 means this minus should be retained, which means minus minus plus, so 1 plus 1 is going to be 2, 4 2s are 8. So if n is an odd number, the function is 8 by n cube pi. If it is an even number, for example, if n equal to 2 means, so minus 1 square is going to be plus 1, so that this minus should be retained, so 1 minus of 1 is going to be 0. So it shows that this function is not available for a function if n is uneven. So now followed by that, f of x is equal to, we just substitute the bn value if n is on odd, so that here if n is on odd to infinity, which means 1, 3, 5, this function is available only for the values 1, 3, 5, 7, etc. with multiplication of sin nx. Now followed by that, if you want to change this odd number to infinity into the natural number 1 to infinity, so now you just have a replacement for this n for 2n minus 1, so that now this odd to infinity will be changed to the natural number, which means 1 to infinity. So replace n by 2n minus 1 here, so that you will get sine of 2n minus 1 into x. So if n equal to 1, 2, 3, 4, etc., you will get the series like this. Now put x equal to pi by 2 for a continuous point here to reduce this series, so and then you will get this series like this. So now you can see that here, as I told you earlier, to reduce the series from the range itself, you can pick the point. So now you can see that in final answer you have a trigonometric ratio sine. When you have sine, it's possible to reduce the series when you have x equal to 0 or x equal to pi, which means sine 0 value is 0, sine pi value is going to be pi. So students can use this logic, which means you cannot apply the value 0 either pi. So it's going to be only the option is going to be the midpoint of this range, which is pi by 2. And sine pi by 2 value is 1, you know about it. And so you can take x equal to pi by 2 here as a continuous point. So after applying x equal to pi by 2 on both sides of the equations, you can reduce this series. So the example number 2, very similar to number 1. Range is 0 to 0, L. 0, L, which means 0 to L, where L equal to 1 here. So half range cosine series, interval is 0 to 1. So here 0 to L is the interval, which means L equal to 1, and formula is here, the Euler's formula for the interval 0 to L for half range cosine series, A0 and then AN. For the sine series, you can only find Bn, which is n of. But in half range cosine series, you have to find the coefficients, the Fourier coefficients A0 also AN. So as usual, formula substitution, 2 by L 0 to L f of x dx for A0, where f of x is given, which is x minus 1 the whole square. So after applying this, we will get this value. Now AN formula is here, f of x cos n pi x by L. And don't forget that here L value is 1. Length is 1 here, and f of x is x minus 1 the whole square. Again the algebraic function. Algebraic function with multiplication of trigonometric ratio, use the Bernoulli's formula. After applying the Bernoulli's, you will get the answer like this, 4 by n square pi square. So after finding A0 value, also the AN value, let's have a substitution here. So after the substitution, you will get the function like this. So again, to reduce this series, you have to fix the point, discontinuous point at x equal to 0. See that at x equal to 0, on both sides of the equations, in place of x equal to 0 substitution, so cos 0 value is 1, so that this trigonometric ratio has been gone. Then on LHS also, f of 0 plus f of 1 by 2. The reason behind this equation is that we just chosen as a discontinuous point x equal to 0. So that after applying this function, we'll get the series like this. So now, out of class activity design 2. And the question number 1, find the Fourier sine series of f of x equal to L minus x in the interval 0, L. You know the formula for 0, L, and the function is here L minus x again, which means in Bn you have to use the Bernoulli's formula. So why I am saying Bn? Because half range sine series. Sine series means you can find the Fourier coefficient Bn only. No need to find the a0 an. And second question, construct cosine series for the function x square in the interval 0, pi. For the cosine series, you have to find both Fourier coefficients a0 also an, and the interval is 0 to pi. To answer our questions, you can also have a team discussion. Now, section 4 in class activity, design 3. Learning objective for this design number 3 is you can deduce the sum of series with the period 2 pi and 2l. You can analyze the point of continuity and discontinuity of period function. Key concepts to be covered: importance of continuity and discontinuity in deduction of a series. So design 3, the content for the interval 0, 2 pi and 0, 2l. So now just have a small glance. In design number 1, we had the interval minus pi to pi and then minus l to l. Design number 2, we had the interval affine sine series, which means 0, pi and 0, l. In design 3, interval is full range, 0, 2 pi and 0, 2l. Formula is very similar. For the interval 0, 2l, a0 by 2, sum of n varies from 1 to infinity, which is the common term for these two Fourier coefficients, an cos n pi x by l, bn sin n pi x by l. For these three Fourier coefficients, we have a separate formula. Formulas are here. The main concept for the Fourier series is that you must strong in Bernoulli's formula, because all the formulas are very similar. They are connecting each other. Now you can see that first question. Before that, 0, 2 pi, the formula is here. Cos nx, sin nx, an, bn, summation n varies from 1 to infinity. As usual, for these three Fourier coefficients, formula is here. So this is the first question. You have to deduce the series for this function n minus x the whole square, interval is 0, 2l. So just write down all these three formulas, followed by that. Start from a0 here, f of x is here, l minus x the whole square, then integration based on variable x. So l minus x the whole square, it is of the form x power n. After integrating this, you will get l minus x power 3 by negative 3. This negative operator came from this coefficient of x, which is minus, and the interval is 0 to 2l. After applying the limit, you will get the form of 2l square by 3. So now an formula is here. F of x cos n pi x by l dx. Again f of x substitution here. Algebraic function, multiplication of trigonometric ratio. So use the Bernoulli's formula, uv minus u dash v1 etc. Range is 0 to 2l. So after applying the limit, you will get the format like this: 4l square by n square pi square. And similarly find bn also. Again l minus x whole square sin n pi x by l. Use the Bernoulli's formula again. After applying the limit, you will get the formula like this: 1 by l into 0. So bn value is 0 here. So I have substitution here. Then as I said earlier, as we have seen in those two designs, put x equal to 0 to deduce the series, either continuous point or discontinuous point. And here you can apply x equal to 2l also. Then followed by that, you can deduce this series. So now example number 2, function is here, interval is 0 to 2l. We have two different functions, and the question is construct bn for the function f of x. They asked us to construct only bn. So directly you can go for the bn. Formula is here. For this interval 0 to 2l, we have two different functions. So that you just try to split the function 0 to l. For this interval, function is here x by l and sin n pi x by l dx, plus second function is 2l minus x by l is there, range is l to 2l, sin n pi x by l into dx. So I use the Bernoulli's formula. After applying the limit, you will get bn equal to 0. So now out of class activity design number 3. So obtain the Fourier series expansion for the function 1 and 2. Range is 0 to 1, 1 to 2 for x plus 2. F of x plus 2 is equal to f of x. It shows that the period is 2 here and the interval is 0 to 2l. Interval is 0 to 2l. So in place of 2l, we are having 2 here, which means 2l is equal to 2 and l equal to 1. So that here, after using that L formula, I mean 0 to 2L formula, you have to replace in place of L as 1. So now the second question, f of x equal to 1 by 2 pi minus x. Find the Fourier series in the interval 0 to 2 pi. To answer above questions, you can use team discussion. So now, design 4. In class activity design 4 learning objective. This is the last design in this unit. Importance of Parseval's identity in construction of a sum of series. You can analyze Fourier series in complex form after reading this design 4. You can construct an infinite sum of series for harmonic function. Key concepts to be covered: Parseval's identity, Fourier's complex form, harmonic functions. So design 4, RMS value, root mean square. So this is the basic definition for RMS. F of x be a function defined in the interval a comma b. Then square root of integral a to b f of x whole square dx divided by b minus a is called the RMS, and it can be denoted by y bar, where y bar square is equal to 1 by b minus a integral a to b f of x whole square dx. So Parseval's theorem is excluding proof, and the statement is let f of x be a periodic function with period 2 pi defined in the interval minus pi comma pi. Then this is the formula for the Parseval's theorem, where a0, an and bn. You all know about these. These are Fourier coefficient. The first question: design the series 1 by 1 power 4 plus 1 by 2 power 4 plus etc. should be equal to pi power 4 by 90 by using Parseval's identity for the function x square in the interval minus pi comma pi. So now in design 1 we have seen minus pi comma pi and minus l comma l in odd or even function condition, but here they have not mentioned as odd even condition but Parseval's identity. It doesn't mean that we don't need to check the odd or even condition. So whenever having the range minus pi to pi or minus l to l, whether it is Parseval's identity, whether it is from design 1, you must go for that whether the function is odd or even. You have to check that first. So here f of x equal to x square, and obviously square is there, function is even, which means bn value is 0, that we have already seen in design 1 itself. So f of x formula can be reduced as a0 by 2 plus sum of n varies from 1 to infinity an cos nx. A0 formula 2 pi pi integral 0 to infinity f of x dx, 0 to infinity, which means here the range is 0 to pi. So after applying the limits, you will get the answer as 2 pi square by 3 for a0. For an, as usual, you can use the Bernoulli's formula. After applying that, you will get the answer 4 by n square into minus 1 the whole power n. Have a substitution, then you will get the equation like this. Now you can use the Parseval's theorem now to deduce the series. So Parseval's theorem formula is here. Bn value is 0, you knew it. An value is there already, we just found, as 4 by n square minus 1 the whole power n. An square means squaring, 16 by n power 4 and minus 1 the whole power 2n. And the LHS f of x the whole square, f of x is x square in question, which is given already. Squaring means x power 4. So both sides integration, LHS side this integration x power 4 after squaring it. So you will get x power 5 by 5. And the right hand side, you just have a simplification. If n equal to 1, if n equal to 2, if n equal to 3, you just try to expand the function. You will get the infinite series. So after a few steps, you will get the series like this. So now, complex form of the Fourier series. Let f of x be a periodic function with period 2 pi, then the complex form of the Fourier series in the interval 0, 2 pi is given by f of x equal to sum of n varies from minus infinity to plus infinity cn e power inx, where cn is equal to 1 by 2 pi integral 0 to 2 pi f of x e power minus inx dx. Also for the interval minus pi to plus pi, 0 to 2l, minus l to l. Formulas are there. They are related to each other. Formulas are very similar. Based on the range, you can rearrange the formulas. So it's easy to remember. Now the first question: in complex form of the Fourier series, function is e power x, interval is minus pi to plus pi. So for the interval minus pi to plus pi, and this is the formula. So now f of x is e power x, e power minus nx is there itself in formula. Adding those powers by taking x as a common term. So now the integration. E power anything is e power itself by the coefficient of x is 1 minus in. So after applying the limit, you will get the formula like this. Here you can see that e power minus in pi expansion is cos n pi plus I sin n pi. Cos n pi value is minus 1 the whole power n. Have a substitution here. Sin n pi value is 0. You knew it. So this is the answer. You can still simplify this. E power pi minus e power minus pi by 2. It can be called as sin h pi. So this is the answer.